Hi there. This talk is about visualization. It's about plots and graphs generated by bundle-weavers out of the data sets collected over the course of the mission. When you click on the View button at the top navigation panel, you will be redirected to this page with a colorful image of the spider plot. On the top right here you can see two buttons, one redirecting to time series, another redirecting to the page with correlations. And I will start with this talk with time series because those time series are easier to comprehend, they're easier to explain, and they give you kind of an integrated summary of what was happening over the course of the mission. As you see here, there is one separate plot for every indicator we will be logging during the course of the mission. The horizontal scale range shows us the number of the record, and in this case it ranges from 0 to a little bit more than 50. The vertical scale is a value which being normalized so that it ranges from 0 to 100, where 0 represents the minimum value and 100 is the maximum value, and those values, minimum and the maximum, they've been entered, they've been set when we were designing those tables from this mission, when we were structuring this mission. The dashed line here is a target value, again set during the design of this mission in those tables we talked earlier in another talk. So in this specific example on this plot, the variable we named it, we called it feel. It represents a subjective perception of the person, of his well-being over the course of the mission. And the target value was 100%, meaning that that person aimed at feeling great 100% of time, but the actual values recorded, as you see, they more often ranged between 60 to 80% of his target value. As another example, let's have a look at the plot with sleep hours over the night. The range again from 0 to 100. 100 could be representing some either 24 hours, the maximum value possible for this variable, or it could be something less, but just keep in mind that all those numbers are being normalized. There are not actual hours, but the scale represents the range between minimum and maximum values. And the target value here, shown as a dashed line, as you see from this plot, this person didn't have enough sleep for quite a large number of nights over the course of this mission. Now, if going back to this page with a spider plot, if we click on the correlations button, we are going to be redirected to this page with correlations. And again, we have a separate plot for every indicator we logged during the mission, and it shows the correlation between this indicator with the rest of indicators we had in this mission. For example, this one shows the correlation between the variable feel with the temperature, the rain, magnetic field, and then intensity, and so on. The correlations in general, the correlation between two variables, it tells us about the relationship between those two variables in terms of the change, in terms of the variations in the values for those variables. It tells us how another variable will respond when we change the first variable. For example, if we move the first variable up and another variable quite often moves up as well, then the correlation between those two variables is positive. If the second variable moves down every time the first variable goes up, then the correlation is likely, it tends to be negative. Okay, and on this plot, for example, as you see, this correlation between sleep hours and the variable feel, they stand out, and there is positive correlation between those two variables. And what it says us, what it tells us, is that this person, whenever this person had enough sleep, or the more sleep hours this person had through a night during this mission, the better he felt during the next day. Now every plot here also has at least one bar with 100% correlation between the variable with itself. This 100% correlation of the variable with itself is something to be expected. There is no news, no new information in this data set, in this result, except probably that it tells us that the code underpinning these numbers, the code we've been using to simulate those graphs, it probably works fine because it's generating the results we are expecting it to generate. All those small bars here, small correlations, that are likely to represent just random noise. So random noise because we had a fairly short record, and in general, the longer the record of data we have, the more reliable those correlations are. And for reliable correlations, the record should be exceeding at least 100, and probably getting closer to 200 data sets, which means if we log those data sets daily, then 200 entries into the record means that you have to stick with the mission. You have to be on track. You have to track your data set for at least half an hour. There are separate issues about how this signal changes with time, with seasons, during the winter time and summertime. And in order to capture this variability as well, then you have to go even longer. You have to use even longer records. Now another point, one more point to mention here is that those correlations usually don't tell us much about the cause and effect relationships between variables, which one has been the cause and which one was the consequences of that cause. Apart from some exceptions, of course, in this specific case, for example, when we talk about the number of sleep hours and the way we felt next day, of course, here you would expect that sleep hours would be the cause or could be the cause of our subjective evaluation of the well-being next day, because those two entries are separated in time, and the variable measured earlier likely to be the cause of the variable measured late. But in general, if those two variables or some other variables are measured at the same time, from the correlation table you may not, so from the correlation relationship you may not infer the cause and effect relationship. Okay, let's get back to the spider chart. The spider chart shows the red colors here are the target values. The target was 100% feeling good for this variable, for example. The yellow plot shows values integrated over the time, or average towards the course of the mission. So on average 68% of time we felt what it tells us that our average performance was 68% out of our target value. Now this yellow plot, and the blue plot shows indicates represents our last entry. Next time when we enter a new record, this blue plot can change quite substantially. The yellow plot is likely to be slightly updated because it represents average value, which are more stable in time, and the red plot unlikely to change at all unless we change the targets for our mission. And that's all I wanted to share with you in this talk. Thank you for your time. Take care.